This project is really about trying to come up with a solution for the 88,000 cesspools that are across the Hawaiian Islands and the impact that they're having both on the groundwater, which is often our drinking water, and then also their impact on the coastal environment and coral reefs and swimming beaches and those sorts of things. There's a higher amount of illness associated with swimming at some of these places where there's a lot of discharge of wastewater. And so, our goal is to come up with a low-cost, nature-based system that can be built very easily on any one of the Hawaiian Islands using locally sourced materials, using local labor, and also helping to provide job opportunities and for local communities addressing some of these issues.
My name is Danielle Rastelli.
Kanoilani Adao.
We both work for the University of Hawaii at Manoa Water Resource Research Center. And for the past 6 months, we've been analyzing samples from Ridge to Reefs Bioreactor Garden, which you can see behind us.
It is located at East Honolulu Wastewater Treatment Plant, and we've been collecting samples for about 6 months now.
There's quite a bit of plant growth behind us, and that is Vetiver Grass, which is a natural plant typical to wetlands in the natural environment. So in order to create a productive system, we try to emulate those characteristics that are seen in nature and in the environment already. So vetiver grass is a really good option. So are flowering plants, so you can also do plants that look pretty that you like, and those are really good at removing pathogens as well. So it does have a lot of flexibility as far as look.
Hi, I'm Joachim Schneider. You can call me Yoko if you like. I am the project coordinator for the nonprofit WAI, stands for Wastewater Alternatives and Innovations, and I'm excited to be collaborating with Ridge to Reefs on this project with the Bioreactor Garden, which is an exciting wastewater treatment system. As you know, in Hawaii, we have a big problem with over 88,000 cesspools polluting our waters, that is streams, groundwater, drinking water, and the ocean. And if you want to upgrade a cesspool to a better system, you have to choose which technology to use. For years, the choice was septic tanks, disposing their water then to a leach field. However, septic tanks only treat a portion of the wastewater, and the rest still goes to the environment. And other options include aerobic treatment units, which treat the wastewater to a much higher standard. However, they use electricity and require high levels of maintenance multiple times a year. And when those things break, they don't treat the wastewater well at all anymore. So the golden grail for the longest time was to find a treatment system that treats it without electricity, but still to the same standard that aerobic treatment units treat it to. And luckily, with Ridge to Reefs, we found a nonprofit that is able to do just that. And so we tested their bioreactor garden, which is a type of constructed wetland. And this treatment system, by means of natural mechanisms with bacteria and plants, treats the wastewater that comes out of a septic tank to a very high standard, even one that is certified by the National Sanitation Foundation's standard number 245, which means nitrogen is reduced in addition to BOD and TSS. And then that wastewater can safely be disposed of by means of a leach field or a seepage pit. And we're very excited to use hopefully many thousands of these systems across the Hawaiian Islands.
Yeah, vetiver is a perennial bunch grass with a very massive root system that can extend deeper than 10 plus feet in some situations. Vetiver has the ability to quickly convert nutrients in wastewater into biomass production, really rapid growth, and it does it really quickly compared to other vegetations. It's a non-spreading grass, it's not invasive. It does produce seeds, but the seeds are sterile, and it hasn't shown any invasiveness here in Hawaii. And because of those characteristics, it became an ideal candidate to use in the bioreactor garden as a way to help consume wastewater that was going through the system.
The inherent strength of a nature-based system is that it can handle ebbs and flows and changes in incoming concentration, and then the system itself will respond. The plants will grow more vigorously, or the bacteria will increase their population to deal with an increased amount of pollution or increased amount of nitrogen coming into the system. And then they'll kind of slowly die back as the concentration decreases. And then they can ebb and flow and continue to perform in a really good fashion. I think that in maybe a more of an engineering-driven system may have less capacity to sort of deal with those ebbs and flows of nature.
Yeah, I think at its core, this project is about us utilizing natural processes that mimic nature and using that to treat essentially residential wastewater, what's known as on-site disposal systems. So this solution is what we've developed to directly address that using local materials. This can be used at a small scale, as I mentioned, individual kind of homeowner scale. But we've also built larger systems, for example, in Puerto Rico, even for a 27-room hotel. It can also be scaled up to provide treatment at even a wastewater plant or at a residential scale, like at a neighborhood scale. So these principles are widely can be observed in nature, and they can be designed at pretty much any scale that's needed. And I would say one of the benefits of this system is that one of the things that contributes to them being easily scalable is that we're not using tons of power or a bunch of fancy pumps. Really, we're using gravity and natural principles to provide the treatment, which is one of the reasons why it can be scaled rather effectively.
The beauty of the system is that it's fairly flexible. We can design this to really take into account the site conditions in terms of spacing and aesthetics. And cost-wise, I feel like our system can be much cheaper than the other alternatives that are currently available to Hawaii residents. And because of that, I think we can easily scale this up. The one thing with new technology is getting the outreach out there so people can learn about it. So those are going to be some of the next steps that we take in the near future to really get this out there, really introduce this to the community and show them that this is a viable alternative that they'll have to be able to choose from when it comes to converting cesspools or when they come to building new homes that are on septic.
Before the system, the bioreactor garden, can be used widely and easily, it has to be first introduced to the local authorities. And luckily, we at VI are good friends with the local State Department of Health and their wastewater branch, who regulate on-site wastewater systems in Hawaii. And we were able to go through a pilot process in collaboration with the University of Hawaii and Reefs installed the system at East Honolulu Wastewater Treatment Plant, where it underwent a 6-month rigorous testing process, which follows the same standards that the National Sanitation Foundation uses nationwide. And it passed with flying colors. It far exceeded the required treatment standards. And luckily, this means that now this report will be submitted to the State Department of Health. And once they give their check mark, which we're anticipating to be happening very soon, then engineers and installers across the state can install the system and design the system for many cesspool conversions, and the system is anticipated to work really well. It's supposed to be very reliable, and we know it will be because it requires hardly any maintenance. The plants, the bacteria that live in there, do the job without any human activity doing anything about it, which makes everybody feel much more relaxed about it than if you had to have people come out a couple times a year and have a look that it still works.
So we have 3 or 4 mechanisms of treatment that are happening there. So we have bacteria that are breaking down pollutants. We have vegetation. We have the vetiver grass that's uptaking pollutants, uptaking water. We have filtration that's happening through kind of a sand or a basalt layer with certain particle sizes. One of the things we've learned about designing on islands where sometimes you have relatively extreme conditions of rainfall or things like that, that you need flexible systems and multiple mechanisms of treatment, and also recognizing that things don't always get maintained the way they're supposed to. So traditional engineering systems that have to be maintained a lot don't always work well when it's hard to get apart. When we're dealing with 2 or 3 different mechanisms of treatment, one cannot be working perfectly, but the other 2 can fill in for it. So we have a system that has almost no parts, no moving parts, because it's a nature-based system.
It's very successful at removing nitrogen, even more so than some of the systems we've been using for years in Hawaii, like the ATU. And so overall, this is a really great system.
It is not only easy because it does the job all on its own. It is pretty to look at because it involves beautiful plants if you wanted to. And it's flesh and forget. People don't have to worry about it. People don't have to check on it. And the Department of Health will agree with us as soon as they see this report. And so the permitting aspect of it is really easy. In Hawaii, any residential wastewater system goes through a permitting process called the individual wastewater system. And that permitting process can be made easy by having these pre-certifications like the equivalent NSF certification that we are achieving right now.
So I think a final thought is just for people to be open toward these types of systems, toward nature-based systems, and also to advocate for our politicians and our decision makers to better make use of natural-based systems that we know have functioned for an eternity, and looking to kind of replicate these types of systems to solve hard problems that we have and that are negatively impacting our water quality across Hawaii, and utilize these systems that we know function and that we know perform well.